For today's notes, you will need in class 60. Double check that this says part 2, the area of rectangles and triangles. All right, so we have two shapes to talk about today. First is the rectangle. In order to find the space inside a rectangle, we need two dimensions. So we need to know the two sides of the rectangle that form a right angle. So it might be the left and the bottom, it might be the left and the top, or the top and the right, or the right and the bottom. Any two sides are fine. We use the terminology of lowercase b and lowercase h for those two sides, and then all we do is multiply them together to give us the number of small squares that would fill up that entire rectangle. When we think about a triangle, what we need to realize is that it is actually half of a rectangle. That's easiest to see when we have a right triangle. If we filled in another matching right triangle here, then it would create that whole rectangular shape. So in this triangle, we can use the same measurements we would have used for the rectangle. So these two sides that form that right angle, this is still the base and this is still the height. But in this case, we don't want to just multiply those because that would give us the whole rectangle area. So that leads us to a formula of BH over 2 or 1/2 BH, where B is the base of the shape. It has to be one of the three sides. And then H is the height of the shape, which sometimes looks like this, but often does not. So the key is that what we're using for our base has to be a side, and then H has to be perpendicular to that. Now, perpendicular is a word that we haven't used in a while, but remember the symbol is that upside down T, which means that our base and our height always have to form a right angle. So if we're looking at this triangle over here, let's say we want to use this as our base. We could have just as easily chosen any of the other sides. Then our height is actually going to start at the opposite corner and make a perpendicular right angle with that base. So it's going to be located inside that triangle. There's the H, and then this whole side here would be the B. If we're dealing with this triangle, again, we could pick any side as the base. I'm going to pick this one. And then in an obtuse triangle, if we pick one of the sides connected to that obtuse angle, the height actually shows up outside of the triangle, and it makes a right angle with the extension of that side that we chose as the base. So the base stops where the triangle side stops. So that's the B. But then that height is found outside the triangle in order to make that right angle, that perpendicular, happen. And so as we go, what we need to do for each of these problems is identify whether we know the base and the height, or sometimes the base or the height will be missing and we'll need to solve for it using some of our old strategies from other standards. Jumping into example 1, it looks like we're in good shape. If we choose this 12 to be the height, then this side here would be the base. Since it's a rectangle, we know that's a nice right angle. And so if we're looking for the area, all we need to do is take that base and that height, so that 8 and that 12, and multiply them together. And that would give us an area of 96. Since there are no units, we can just say that it's square units instead of inches squared, square inches, or square miles, or square centimeters. If we slide to example number 2, we're in a little bit of trouble. We do have a base that we can use, same as before, but our height is missing. Now, sometimes the first place we look for it, it doesn't show up, but if we look at the parallel opposite side, we might find it. We're not lucky there, so we don't have it. What we have is this diagonal here, which is not helpful in terms of area. However, what I'm noticing is that in this triangle, that 17 is across from the 90, and I know one of the other two sides. So this is bringing back to mind that c squared equals a squared plus b squared Pythagorean theorem that we've used in the past. So we're going to plug it all in. 17 squared equals 8 squared plus, I'm going to put h in because that's what I'm solving for. 17 squared and 8 squared need to be simplified. Subtract 64 from both sides. and square root. And in this case, we come up with a nice exact answer for the height of 15. So now that we know our base and our height, we can go ahead and find the area by multiplying those two numbers together. And this time around, 8 times 15 is going to be 120. Again, there are no units given, so square units. Moving on to number 3 and 4, I can see I'm going to be in a similar situation because I do not have both the base and the height given to me. In this case, most people would probably call 12 the height. But then when I'm looking down here for the base, I don't see it, and it's also not listed on the parallel congruent opposite side. So if we put our right angle in here and we notice that 30, that means that this is 60, and now all of a sudden, I feel like I'm going to be in my 30, 60, 90 special right triangle stuff. I'm going to use a different color for a minute. The side across from 30 is the shortest, so remember we make that equal to L. I'm looking for the side across from 60. That's going to be the one that's equal to L root 3. So that means my base is equal to L root 3. Since 12 is L, I can plug that in, and that tells me my base is equal to 12 root 3. So now that I have base and height tracked down, I'm ready to find the area by multiplying those two together. So multiplying 12 root 3 by 12. Now this problem in the instructions tells us to give an exact answer, just like all the others have. In the others, there wasn't another option, but if I'm going to give an exact answer for this one, that means I'm not going to be able to multiply everything together because that root 3, if it enters the calculator, will cause an approximate answer, a decimal. So this will just take the 12 times the 12, leave the root 3 multiplied next door, and then we'll have units squared again, since we don't know if they're centimeters or inches or some other set of units. Number 4 is similar. We have a height, most people would call it, but we don't have the base that we're looking for. And that 58-degree angle is not going to be an angle that is helpful in terms of 30, 60, 90s, or 45, 45, 90s. So I think this one is going to be where my SOHCAHTOA is going to come in and help me out. This would be the adjacent side. The base that I'm looking for is the opposite. So I'm going to go ahead and put a B there so that I can remember that's the goal. When I have an adjacent and an opposite available, that is a tangent equation. So tangent of 58 would be equal to opposite, which is the base I'm looking for, over adjacent, which is 11. Since the variable is over there in the fraction, I need to multiply by whatever's in the bottom. And in that case, that's all I need to do to solve for my base. So the base is going to be 11 tangent of 58. Well, that's going to be an approximate answer. However, this is not the final answer to my problem. So I want to make sure that I have extra decimal points available so that I don't end up with something that's called rounding error. So even though eventually I'm going to leave my answer rounded to 2 decimal places, for right now, I'm going to leave several more. So 60, let's go for 4 decimal places. 6037. And better yet, if I leave this whole decimal on my calculator screen, I'm going to come back to that in a minute when I'm solving for my area. Area will tell me I need to do base times height. So that base, 17.6037 with a bunch of other decimal places attached, is going to get multiplied by that height that I highlighted earlier, so 11, which is why I said to keep that decimal on your screen, because now that you have that sitting there, you can just click times 11, and it will take that whole decimal and multiply it by 11, which means we're avoiding what we call round-off error, because that whole exact number is in there where that answer is typed, and then it gets multiplied by 11, and we can officially round now at the end of the problem instead of along the way. And those should be my squiggly equal signs since the area is approximately 193. All right, continuing on to number 5 and 6. See if I can get it to show up here on the screen. we're shifting into triangle mode. So for triangle mode, we still need to identify the same kind of base-height relationship for our formula, but we need to make sure the base is a side of the triangle and the height is something that's perpendicular to that from the opposite corner, the opposite vertex. So I see my right angle right here in the picture, which means this side is what I'm going to use as my base, and then from that opposite corner, I see a perpendicular segment that I can use as my height. What that means is that the 6 and the 8 are just there to distract you. Since it's a triangle, we're going to add that divided by 2 onto the formula. So we're going to take our 12 base times our height of 5 and then divide by 2 to come up with the official final area of 30 square units for that triangle. Moving into number 6, we're going to be on the lookout for the same thing. I spot my right angle here. So that means that one of these two sides is going to act as my base, and then from the opposite corner, perpendicular to that side, will act as my height. So this time around, they're both sides of the triangle, instead of being inside the triangle as the height was in number 5. Now, unfortunately, I don't know either of those, but I do have a 30, 60, 90 triangle. So if I think about the side across from 30 being the shortest, the one across from 90 being 2 of those shortest legs, and then across from 60 being the L root 3 side. If 16 is equal to 2L, we can divide that by 2 to figure out what L is. Plug it in everywhere it goes. So that tells me that the base of this triangle is 8, and then 8 root 3 is the height of this triangle. Since we're in triangle mode, we're going to do base times height divided by 2, which means 8 times 8 root 3 divided by 2. Do a quick check of the instructions. It says we're to give an exact area, or an exact answer. So 8 times 8 on top will sit next to the root 3, but then 64 divided by 2 stays nice and exact. So that completely simplified exact answer would be 32 root 3 square units. All right, we are ready for the back. So go ahead and flip that page over. We've got a couple more triangles back here. So we are going to continue to be on the lookout for a side that can act as a base and something that forms a right angle with that base as well. So if we're looking at this picture, the right angle is right here. So if I follow that back, that indicates to me that right there, so the 12, is going to be the base. That's the side of the triangle that we're going to use. And then that opposite vertex drops down the height to be perpendicular with that little extension. That 4 is not used in the problem because that's not actually part of the side. That's just how far that little extension happens to take you over to where the height is at. One more time, we're dealing with triangles, so the formula would be base times height divided by 2. 12 times 6 divided by 2 will be 72 divided by 2, or 36 square units. All right, number 8, one more triangle. And this one is different than all of the others because there's no right angle in sight. So we have to think a little bit more creatively on this one about how to divide this triangle up to create a height that we will be able to solve for. The way that we want to do that is actually by using this side here that's different from the other two to be the base. And the reason for that is that if that's the base and I drop my height in to be perpendicular, something really important happens in this triangle. Since these are both 18, we know this triangle is isosceles. That means that these two angles match. These would both be right angles. And then this side right here is congruent to itself, or these two sides are congruent. And so that makes these two little half triangles congruent by angle, angle, side. If that's the case, then this turns out to be split in half, 7 and 7. And then my height can be solved for by focusing on one of these little half right triangles. If I pull that out of the picture so that you can see it a little bit better, what we have is a missing height, an 18 across from the right angle, and then a 7. With no other angles given, my only option is to consider the c squared, a squared, b squared formula, and I definitely have enough to use that to help me to solve. So we're going to think about 18 as being the hypotenuse, 7 and h as being the other two sides. 18 squared is 324, and 7 squared is 49. So if I do 324 minus 49, that gives me a 275 for my h squared. And now I square root that 275, and I end up with a decimal, which means I need to check my instructions. This says to give an exact answer, so that means it's not acceptable for me to call this the height. It's also not acceptable for me to call that the height, because then my exact answer won't be simplified. So I'm going to need to go through whatever simplifying process you used in previous problems to figure out what the square root of 275 is. That might be factor trees, that might be factor tables, it might be on the hunt for a perfect square. So you pause real quick and go through that process, and then when you come back, you can double check to see if you've simplified that radical correctly. All right, welcome back. You should have ended up with 5 root 11 as your value for that height. If you need help simplifying radicals, that's a great topic to talk to your teacher about during RTI, or to go visit some of our old videos from Standard 11. All right, now that we have our height and we have our base, we're ready to take those values and plug them into our area formula. Base times height divided by 2. So 14 times 5 root 11 divided by 2. Remember, keeping the exact area idea in mind, we're going to do 14 times 5, but leave the root 11 attached, and then 70 divided by 2. So our final official exact answer for the area of this triangle is going to be 35 root 11 square units. All right, we have 2 problems left that are asking us to find the area of each composite shape, and then we're asked to determine the geometric probability that a randomly chosen point inside the figure somewhere lies in that shaded region that's been given. So we have 2 problems to do for each of these, which means we've got a little bit more to do in order to make that happen. So first things first, this composite shape is made out of a rectangle. So composite is equal to a rectangle plus a triangle. So if I'm thinking about the rectangle part of this, come down here a little bit. The rectangle is supposed to be found by doing base times height. I see that as being my base, and then I see that perpendicular side there as being the height. So that part looks relatively simple. We're going to do 12 times 27, and 12 times 27 is equal to 324. Square units, of course. That's the rectangle part. So we are part of the way there. Next up is the triangle, which is a little bit small and difficult to see, but I can see that this is 12 and 12, and I actually know that this third side is 12 as well. Plus I have this clue about the 60-degree angle there. But if I know that this third side is 12, then this thing I'm betting is supposed to be the height that separates those 2 equal sides, which means that that 12 gets split up 6 and 6. And so now that 6 is across from 30, which means that this height that I'm missing, I don't think I'm going to be able to squeeze it in there, but that height would be the L root 3 side. So that would be 6 root 3. So the triangle part of this calculation, BH over 2, is going to have the same base, I should probably highlight that so we can see it, as the rectangle, but it has a different height. So 12 is still going to be the base, but the height is going to be that 6 root 3 that we just figured out with the help of that 30, 60, 90. Again, keeping our answers exact, that would give us 72 root 3 over 2. Sorry, I ran off the screen there. And then that would be 36 root 3, completely and totally simplified. I'm going to go ahead and add 36 root 3 to that. And then if we double check, it does say round all answers to 2 decimal places if needed. And I'm glad that it says that, because in order to add 324 to 36 root 3, I'm definitely going to be rounding. 386.35, it looks like. 386.35 square units. Okay. Now remember, we have 2 parts to this problem. The next part of the problem actually asks us for the geometric probability that a randomly chosen point lies in the shaded region. So if we're thinking about probability, remember we're going to use that fraction where we have the desired area. So the shaded area to me looks like that rectangle. And then we have the total area on the bottom. Looks like that screen got a little fuzzy, so let me go ahead and refocus here. Now, before you get too frustrated, I think we have everything we need to take care of that. The rectangle area was 324, and the total area would be what we just found, that 386.35 number, but remember that was rounded. So if possible, it would be good for us to be able to take 324 and divide it by this answer. A lot of calculators can do that because down here at the bottom, they have a little purple or blue A and S above that negative sign. So we can type in 324 divided by, and then click that answer button, and it will pull up that previous answer and plug it into the denominator for us. If you can't figure that out on your calculator, you can certainly ask your teacher, but that's your probability. You can either round to 4 decimal places, remember, or you can move it 2 decimal places and write it as a percentage. So 0.8386 would be our probability, 0.8386. And now we have both parts of that problem taken care of. All right, we're on to the very last one, and it looks like this very last one is another situation where our composite shape is made out of a rectangle and a triangle put together. The rectangle, again, gives us the base and the height information that we need. So we're going to be able to jump right in and say that our rectangle equals base times height, which is 9 times 16. 9 times 16 is 144, and we've got part of the problem taken care of already. Now, taking a look at this triangle, I'm noticing this is going to be a little trickier. I see the right angle. I'm going to switch to a different color here, which means I can use this side of the triangle as the base, and I can use this side of the triangle as a height, but what I don't want to do is make assumptions. Now, it is perfectly fine for us to call the height 16 because that's opposite and congruent to that side of the rectangle. What we can't do is grab this 9 and call it the base. There's no reason why these would have to be the same. So we're going to put a B here and then realize that we can use that Pythagorean Theorem again to help us solve for that missing base that we need. So our C squared will be 20 squared equal to 16 squared plus B squared. 400 equals 256 plus b squared. Subtract that over and it will leave you with 144, which just so happens to give us an exact answer of 12. So that base for the triangle is actually 12. If we take that and the height and we plug it into our base times height over 2 formula, we'll have 12 times 16 all divided by 2. 12 times 16 is 192. I'm going to go ahead and divide that by 2, and we get 96 as our triangle area. So that composite, we'll take those and we'll add them together. Composite area will be 240 units squared. Last but not least, they ask us for probability again of that shaded region. This time the shaded region is a triangle, and we want to divide that by the total. The good news is we already have the triangle, 96. We already have the total, 240. So all we need to do is 96 divided by 240, and then we can either report that as a decimal, a fraction, or a percentage. So in fraction form, that one would be 2/5. In decimal form, that would be equal to 0.4000 if we had 4 decimal places, or we could do 40%. So lots of different ways to report that probability. All right, that's it for today. Thanks for watching. We will see you back in class.